Welcome to the Math Record. Today we'll be covering the CCML Algebra 1 Contest 5 2016-2017 Division A. Okay, question 1. Determine the sum of the zeros for 3 times y to the power 3 minus 39y to the 2 minus 104 times y is equal to 0. So for like a polynomial question, the sum of the zeros, which includes the imaginary and the real one, is basically whatever you have for the second value, which is this is a cubic, so you have to look for the quadratic one. So the y to the squared, it's negative 39. You take the negative of that, so the negative minus negative 39 of that coefficient, and then you divide it by the coefficient of the first one. And that should get it out to 13. So the answer is 13. There's a little tip and tricks. Number 2, solve for p. 5 divided by p plus 2 is equal to p divided by 3. So cross multiplying, you get 15 is equal to p squared plus 2p. So you have p squared plus 2p minus 15 is equal to 0. So you have p plus 5 and p minus 3. So p could equal to negative 3 or 5. So that's your answer. I mean, sorry, 3 or negative 5. Okay. Question 3. Simplify square root 27 minus square root 25 plus 5 square root 12. So 27 is just 3 to the power of 3. So that's the same thing as saying 3 square root 3. 75 is just 25 times 3, so that's just minus 5 square root 3. That's 25 times 3 is 75. And then 12 is just 2 squared times 3, so this would be 10 square root 3. Because then if you take out the 5 here, that's 2 square root 3, that's 4. 4 times 3 is 12. So adding that together, that's negative 2, and that's 8. So the answer for number 3 is 8 square root 3. Number 4, determine the quotient of the 20th and 40th digits of 3 divided by 13. Write your answer as a common fraction. Determine the quotient of the 20th and 40th digit. So if you kind of use your calculator, you have 3 divided by 13. You get 0.23076.9, and then it kind of repeats these 6 numbers over and over again. So the first this would be considered the first term. So this would be the second. So the 20th, since it repeats every single 6 times, that means the 20th would be minus 20 minus a 6. You can minus 6 3 times, so you can minus 18 because it's gonna cycle 6. So it's gonna cycle 3 times, and it's gonna be the second number, so it's gonna be 3. And the 40th digit, it's gonna cycle 6 times because it's 6 each, so that minus 36. So 40 minus 36 is the 4th. So it's gonna be the 4th one, which is 7. So the quotient of the 40th and the 20th and the 40th term is just 3 divided by 7. Because quotient means dividing, so it's just 3 divided by 7. Question 5. Determine the function gx is equal to x squared minus 3x minus 4 divided by x plus 2 divided by x minus 4 divided by x squared plus 7x plus 12. Determine the product of all values that are not in the domain of g of x. So all you have to do is you gotta simplify this, and then you gotta look for the denominators there, and then you just have to take out the denominators for these. So we have x minus 4 and x plus 1. Okay, all over x plus 3. Since you're dividing, it's basically just multiplying by the reciprocal. So multiply x minus 4 is on the bottom. And this one would be x plus 3 and 4 plus 3 and x plus 4. Okay. So using the idea, you cross these out, you cross this out, x plus 3 and x right here. So technically in here there is all values all work, so you don't have to worry about the uh actually yeah, so based on this graph right here, you can't make these undefined. So you can't put a -3 and you can't put a 4. And from here, when you look at this value, we have x squared plus 7x plus 12. What it is that you get also these cannot be 0 because these individual functions cannot have a denominator 0, and when you do the reciprocal of it, this side can also not be 0 because you can't divide by 0, you know. So, because you imagine, if you put 4 here, that'll be divided by 4 minus 4, which is 0. And whatever you divide by is 0. So this is just divide by 0, which is not possible. So those are the 3 cases. So you have -3 and 4 for that case. And then you have the second case, which is the one under the first one, which is -3. And then the third case, which is just x squared plus 7x plus 12, which factors out to x plus 3 and x plus 4. So, you already got -3, and now you just have to put -4. So multiplying that together, you get -3 times 4 times -4, and you get an answer of 48. So your answer for number 5 is 48. The product of all the values that are not in the domain. Number 6, a parabola passes through the points 2, 5, and 8, 5. And its vertex passes through the points h and -13. The equation of the parabola is written in the form ax squared plus bx plus c. Determine the value of c. So the general value, general picture is that you have 2, 5, right? So you have 2, 5, so somewhere around here, and you have 8, 5, and they're the same point. So since they're the same point, if we had to do equal distance from both of those sides, right, that would technically be at the vertex. So we just have to find the equal distance between 2 and 8. So 2 plus 8 is 10, and 10 divided by 2 is 5. So the x value of the vertex, so h, is 5. So it's basically just that simple. So we have those 3 points. So we could just kind of put it in vertex form, so we know it's 5, so x minus 5 squared, and then minus 13, because that's the vertex form. Now we just have to find a. So y is equal to that. So plugging in 2 is equal to 5, so 5 is equal to a. That's -3, so that's 9. Minus 13. Add that in, 18 is equal to 9a, so a is equal to 2. So we just need to put 2 in there. Right? So expanding that out, we get y is equal to, this is x squared, so this makes 2x squared. This is minus 5, which if you factor out is minus 10, so that's minus 20x. And that's plus 25, and that's plus 50. 50 minus 13 is plus 37. So the answer for 6, determine the value of c, which is the last one, is just 37. Okay, number 7. 1/8 x to the power -4, y to the power 2, all in parentheses, to the power -4, times 4 times x to the power -3 times y to all to the power all to the power 5, divided by 32 x to the power 7 times y to the power -4 to the power 3, can be written in form 2a, xb, and yc. Compute the product of the exponents, basically. So let's kind of write this out first. So we have -2 that has to the power -4. And we have, oops, sorry, we have -2, wait, sorry, 2 to the power of -3. Sorry about that. Which is equal to 1/8 power to -4th. So that kind of simplifies out to 12, right? So yeah, 2 to the 12. And then we're going to do the same thing. So x to the negative 4 times x to the negative 4 to the power of negative 4 is just x to the 16. And then y squared times 4 is just y negative 8. And then you have this one, which is 4 squared. 4 is just 2 to the power 2, so this is just 2 to the power 10. And this is x to the power of negative 15, and this is y to the power of 5. All divided by 32 is just 2 to the power of 5, so 2 to the power of 15 because it's multiplied by 3, x to the power of 21, and y to the power of negative 12. So using that idea, this is 2 to the power of 22, adding them together, 12 plus 10 is 22. 22 minus the 15 is 7, so this is 2 to the power of 7. Times x is 16, this is negative 15, so that makes 1. 16 minus 15 is 1. And this makes 1 minus 21 is negative 20, so x is equal x to the power of negative 20. Y to negative 8 and y to 8, that's negative 3. Negative 3 minus negative 12 is plus 12, so you're going to have y to the 9. So determine a times b times c, so 7 times 20 times 9 is, 7 times negative 20 times 9 is negative 1,260. Basically just that simple. Number 8, multiply x squared plus 3x plus 4 and 5 minus 4x minus x squared. Determine your answer in descending powers of x. So usually when I do this, I just put them both in like the form, like quadratic linear and then to a constant. Even if it's negative, so we have negative x squared, negative 4x, and then plus 5. So then we multiply those quadratics together, so you get negative x to the power of 4. That makes, then I work with the cubic. So then there's only two cases for cubic, is when this quadratic is multiplied by the linear. So this is negative 4x cubed, and this is negative 3x cubed, so that's negative 7x cubed. There's 3 cases for a for quadratic. There's the quadratic here multiplied by this linear, and the linear the quadratic of the second term multiplied by the linear of the first term. I mean, not the linear, the constant of the first term, and then both the linears of both of the terms multiplied together. So the 3x minus the 12x makes negative 12x squared. So that's a quadratic. So we have 5x squared, negative 4x squared. So that just already gets 1x. That just gets 1x squared remaining, and then you have negative 12x squared. So negative 12 plus 1 is negative 11x squared. And then same case with not the same case is to get the linear term, you just multiply the linear by the constants. So 3x times 5 is 15. 4 times negative 4x is negative 16. So negative 16 plus 15 is negative 1. And the constant is just the constant times constant. So 4 times 5 is 20. So the product, which is your answer for number 8, is negative 4x squared minus 7x to the power of 3 minus 11x to the power of 2 minus x plus 20. Number 9, 1 over the square root of 1 plus the square root plus 1 plus the square root of 1 plus can be written as a plus square root b over c, where a, b, and c are integers. Determine the smallest possible value of a plus b plus c. So we're going to work with what I refer to as the infinite radical. So we're going to denote this as x. So x is equal to square root 1 plus square root 1 plus square root 1 plus etc. Whatever the denominator is. Now you're just gonna, when you see this, it's infinite, but what you're gonna have to do is that you're gonna have to find where the pattern stops. So x is equal to the square root of 1 plus x. Because x could be substituted right here, right? Because it's basically the same thing as it goes on, right? So you just put an x. And now you just have to solve for x. So you have squared, so you get x squared is equal to x 1 plus x. So you have x squared minus x minus 1 is equal to 0. So based on this, put this up, we could use the quadratic formula. So that gets us, which is negative b plus or minus b squared, the square root b squared, which is 1, minus 4ac. 4, a is 1, and c is negative 1, all over 2a, so 2 times 1. So that gets 1 plus or minus, that's plus 4, so that's 5, so that's square root 5, all over 2. So since it's 1 plus square root 1 plus square root 1, since it's all positive, it's going to generally be positive. That means it can't be 1 minus square root 5 over 2, because 1 minus square root 5 over 2 is negative. So the only possible answer is 1 plus square root 5 over 2. So that's going to be our value of x. So x is equal to 1 plus square root 5 over 2. So that's just 1 over this number. So it's basically you're just putting 1 over x. Because x is square root 1 plus square root 1 plus square root 1 plus square root 1, etc. until infinity. So 1 over this number is basically just the reciprocal. So 2 over 1 plus square root 5. And then you multiply both sides by negative 1 plus square root 5. Negative 1 plus square root 5 in the denominator and the numerator. So you get negative 2 plus 2 square root 5. And that gets negative 1. That's plus square root 5 minus square root 5, so those cancel out. And this is square root 5. So 5 minus 1 is 4. So this simplifies out to negative 1 plus square root 5 all over 2. So where a and b and c are integers, determine the smallest possible value of a, b, and c. So that would be 5 plus negative 1 plus 2. So that would be 7 and 6. So the answer for number 9 is 6. Number 10, solve for the intersection of the two graphs. X squared plus y squared is equal to 1, and y is equal to 5 over 12x. Determine your answer as the x-coordinates x, y. So you basically just substitute the second equation in the first equation. So x squared, substitute the y, so you get 25 over 144. X squared is equal to 1. So 144, this is basically 144 over 144. So adding that together, that's 169 over 144. X squared is equal to 1. So x squared is equal to 144 over 169. So square rooting both of them is just plus or minus. So it's positive or negative 12 over 13. Because 144 is just 12 squared and 169 is just 13 squared. So x would just be plus or minus 12 over 13. So x is equal to plus or minus 12 over 13. Now we just plug this back into our equation to get our points. So we got 12 over 12, 13. And then you multiply by 5 over 12. So this is 5 over 13. And we get negative 12 over 3. Plug it in. You get negative 5 all over 13. So these are our 2 points. 12 13th, comma 5 13th. And negative 12 13th, negative 5 13th. Okay. Number 11. For some radius r, the numerical value of the circumference of a circle with radius r would be twice the numerical value of the volume of a sphere with radius r. What is the value of r? So for some radius, the numerical value of the circumference of a circle. So the circumference of a circle is 2 pi radius. And they're saying that would be twice the numerical value. So since this is 2 times it, you have to multiply 2 from the other thing to get it to the same amount. Twice the value of the volume of the sphere. So the volume of a sphere is 4/3 pi radius cubed. And what is the value of r? So we just need to find r. So we're just gonna move everything to one side. So we have 2 pi radius minus 2 times 4 is 8. So that's minus 8 over 3 pi radius cubed is equal to 0. So we can factor out the 2 pi r. So that makes 1, and that makes 4 over 3. Take out the pi, take out r, so that's r squared is equal to 0. So technically r cannot be 0 because this is like a kind of like a quadratic. I mean a polynomial. So r cannot be 0, even though it says it could be, because if r is 0, then this entire thing is gonna become 0. But r can't be 0, so that's not a thing. So now we have 1 is equal to 1 minus 4 over 3 r squared. So that's 1 is equal to 4 over 3 r squared. So multiplying both sides 3 and 4, we get 3/4 r squared. So square rooting both sides, we get square root 3 over 2 is equal to r. R cannot be negative, so the only possible answer is the positive version, which is negative. I mean square root 3 over 2. So that's 11. Number 12, the sum of x and y is 11 squared 3, and the sum of the squares of x and y is 31. So they say x plus y. Let's write it more on the side. X plus y is equal to negative 11 square root 3, and the sum of the squares, so x squared plus y squared, is equal to 31, basically. So these are our two things that were given. Determine the product of x and y. So this is imagine like expanding out like a two variable like kind of system. So you have x and y. So imagine instead of like x squared plus y squared, it's x plus y squared. That will be equal to just the same thing. If you strip it out, it's x squared plus x times y, which is y. So and then y times x is 2x. Is add them together is 2xy plus y squared. So technically, x plus y squared, which is right here, so x plus y, is just negative 11 square root 3 to the squared is equal to x squared plus y squared, which is 31, plus 2xy. So now we just have to find the product. The product is just x times y. So we just need to use your calculator and solve this out. So negative 11 square root 3 squared is 363. And then you minus the 31. And then you divide by 2. And you get x times y is equal to 166. Sorry, 166. Yeah. So the answer for number 12 is 166. Number 13, the harmonic mean of a set of numbers is defined as the reciprocal of the arithmetic mean of the reciprocal of the numbers. So if the harmonic mean of 1, 2, and x is equal to x, determine the value of x. So let's determine what this means. So harmonic mean is defined as the reciprocal of the arithmetic mean. So 1 over the mean of whatever. The mean is the reciprocal of the numbers. So the mean of 1 all over reciprocal of 1 and the reciprocal of 2. So reciprocal of 2 is 1/2. And the reciprocal of x is just 1 over x. So the arithmetic mean, so add these 3 numbers, right? And then the arithmetic mean, you just divide by 3. So you just multiply by 1/3. And then you took the reciprocal of that, which is the harmonic mean. And then it's equal to x. So that's what it's saying. So let's just move 3 on the top already. So 3, that's 1, that's 1/2. So that's 3 over 2 plus 1 over x is equal to x. Let's move this up. Okay. Now we multiply 3 over 2 plus 1 over x to this side. So we have 3 is equal to 3 over 2x plus 1. So minus 1, that's 2, is equal to 3 over 2x. So x is equal to 4 over 3, which is basically what you're looking for, though, which determine the value of x, which is just 4 over 3. Okay. Question 14. Solve for xy if 18 to the power of 3x times 32 the power of negative 1 to the power of y minus 3 is equal to 36 7x plus 2y. So we have 18, which is basically the same thing as 3 squared times 2. So this expands out to 3 squared. 2 times 3x is 6x times 2, which is just 1. 2 to the power of 1 because of 18. Times 3x is just 2 to the power of 3x. Times 32, that's just 2 to the power of 5. So since there's a negative 1, so 32 raised to the power of negative 1 is just 2 to the power of negative 5. And to the power of negative 5, there's a y. So negative 5y. And negative 5 times negative 3 is plus 15. And 36 is basically 2 to the power of 2 times 3 to the power of 2, because that's 4 and that's 9, that's 36. So 2 to the power of 2 times 3 to the power of 2. So this is equal to 2 to the power of 2 times 7x plus 2y is just 2 to the power of 14x plus 4y. And 3 is basically the same thing, which is just 3 to the power of 14x plus 4y. So they're trying to say using this, we can make like a system and equation, one for the 2's and one for the 3's. Okay, for the 2's, we have 3x and negative 5y plus 15. So adding that together, we have 3x minus 5y plus 15 is equal to the 2 here, which is 14x plus 4y plus 4y. And for the 3's, we have just 6x. So 6x is equal to 6x is equal to 14x plus 4y. Okay, so those are the systems that we need to solve for. So getting everything to like basically one side, we have 15 is equal to 11x for the first equation, and then plus 9y. And we have 0 is equal to 8x plus 4y. So now we just need to solve for x and y. Okay. So multiply the first equation by negative 4, so that's negative 60, negative 44x minus 36y. Multiply the second equation by 9, so you get 0 is equal to 72x plus 36y. And then together, you cancel out the y's, and then you just have negative 60 is equal to 72 minus 44, which is equal to 28x. So negative 60 divided by 28 is negative 15 over 7. So x is negative 15 over 7. So x is negative 15 over 7. So if x is negative 15 over 7, that means y is equal to, so negative 15 divided by 7. I'm using the second equation times 8. And then you get that to the other side, so that just gets 120 over 7. And you divide by 4. So y is 13 over 7. So solve for xy. This is our answer. Negative 15 over 7 and 30 over 7. This coordinate is xy. Okay, number 15. If x plus 1 over x is equal to 3, determine the value of x6 plus 1 over x6. So let's just like start using examples. So we have x plus 1 over x is equal to 3. So now we have to find x squared plus 1 over x squared, basically. So the only thing we could do to make this squared is that it's like a quadratic, so we square both sides. So if we have this one is squared and this one squared, so that was multiplying this out, this get x squared, x times x, 1 over x is 1. So the opposite also is true, so that's plus 2. So x plus 1 over times 1 over x is just 1, and then 1 over x times x is 2. So you just factor it out, so 1 over x squared is equal to 9. So this means x squared plus x over 2 is equal to 7, because you minus, the 9 is minus the 2. So we have that. Squared plus 1 over x squared is equal to 7. Now, imagine what happens when you square this one now. So we could get x fourth, because x squared times x squared, and then x squared plus 1 over x squared is just 1. And then 1 over x squared times x squared is just another 1, so that's just 2. And then 1 over x squared times 1 over x squared is just 1 over x to the fourth. And 7 squared is 49. So this would get us to x fourth plus 1 over x fourth is equal to 49th minus 2, which is 47. So we need to find x to the 6th. So based on this information, if we kind of multiply x squared and x fourth, we could get like the x6 term. So let's see what happens when we do that. So that x6, x squared times x fourth, and then you have 1, and then x squared times 1 over x over 4 is 1 over x squared. And then x4 times 1 over x to 2, which is plus x squared. And then 1 over x squared plus 1 over x to the fourth is 1 over x to the sixth. And then that means 7 times 49. So 7 times 47 is equal to 300. So this is equal to 329. Sorry, I'm running out of space. So let's move this up a bit. Basically, don't need that one. So from this information, we get x to the power 6 right here, and 1 plus 1 over x squared. So that's what we need to find, which is equal to plus 1 over x squared plus x squared is equal to 329. So 329, we had to minus 1 over x squared plus x squared. So we had to minus these terms out. And we already got these terms. This one's right here. So it's just 329 minus 7. So x to the power 6 plus 1 over x to the power 6 is equal to 322. This is just 329 minus 7. So that's basically how you do it. Okay, question 16. Determine all real solutions to y minus 7 square root y is equal to 8. So let's just move the radical all to one side and the other terms to the other. So you have y minus 8 to one side. So you subtract 8 from both sides, and you add 7y squared to the other side. Now you're going to square both sides, so you get y squared. Negative 8, negative 16y, plus 64 is equal to 7 squared is 49, and square root y squared is just y. So that gets y squared minus negative 16 minus 49 is negative 65. Y plus 64 is equal to 0, which this could be factored out to y minus 64 and y minus 1. Okay. So y could be either 64 or y is equal to 1. But since there's a radical, this tells me that only one of these answers kind of work. So 64, when you plug it in, that's 64 minus square root 64, which is 8. So 64 minus 7 times 8 is equal to 8. So 64 works for y. And now if y is equal to 1, so that's 1, minus 7 times square root 1, which is just 1. So that makes negative 6, which is not equal to 8. So y is equal to 1 is not an answer. So the only possible answer is y is equal to 64. Question 17. Multiply square root 8 plus square root 3, square root 27 plus square root 2. So the first thing we should do is that we should just factor them out. So square root 8 is 2 to the power 3, which is just 2 to the square root 2. So that's 4, and that's 8. So 2 squared times 2 is just 8. And then square root 3 is just already factored. 27 is 3 to the power 3, so that's just 3 square root 3. That's 3 squared is 9 times 3 is 27. And square root 2 is already basically factored. So Now we just multiply them together, so that makes 6 square root 6 plus 2 square root 2 times square root 2, which is the square root 2 just makes a 2, so that makes a 4. And square root 3 times 3 square root 3, so the square root 3 just make a 3, so that plus 9. And square root 3 times square root 2 is square root 6. So this gets us 7 square root 6 plus 13. So the answer for number 17 is just 7 square root 6 plus 13. Oops, sorry. Okay. Question 18. For a rational function f of x, 5 plus 6x over 7x minus 8, as x increases without bound, so it goes to infinity, so x becomes a really big number, what does f of x approach? So this is kind of like a pre-calculus question. So it's basically like testing your knowledge on like what happens when like a number becomes really big. So we're just gonna write it in like the like normal form for 4. So f of x is equal to 6x is the linear term and then the constant term. So 6x plus 5 all over 7x minus 8. So as a really big number, like x becomes a really big number, 6x becomes such a big number that like 5 doesn't matter if you think about it logically. So you kind of think about it, the only thing that really matters from this equation is the 6x over the 7x, right? Because like as it becomes such a big number, who cares if the negative 8 affects the 7x? Or who cares if the 5 affects the 6x? Because if x is going to be like 1 million, then 6 million is not going to be affected by 5 too much. So what happens is that as it approaches infinity, then it approaches 6x over 7x, basically. So then the x kinds of cancel each other out because they're the same thing. So it kind of approaches 6 over 7. And that's what it will be referred to as the horizontal asymptote. So 18 would just be 6 over 7. Number 19, x times y plus y is equal to 3, where x and y are integers. Determine the sum of x and y. So let's get this into a form that we kind of like are able to understand. So x times y tells me that we have to multiply x and y. So let's have a x here, parentheses, and y here in the other parentheses. So since we have only one x, let's just add 1 here and add 1 here. So that's x times y is xy, which we already got. X times 1, which is x, that's good. So 1 times y is y, and 1 times 1 is 1. So we have an extra 1 on the side, on the left side. So we have to add a 1 to the 3. So it's equal to 4. So now we set, since x and y are integers, determine the sum of all possible values of x. Since x and y are integers, that means adding 1 or to each of them would just only make integers. So integer times an integer means that they're basically factors of 4. So we have to find factors of 4. So 4 could be made out of -1, -4. Actually, let's just write the factors out by itself. So you have 1 and 4 and 2 and 2. So technically the negative versions are -1 and -4 and -2 and -2. So determine the sum of all possible values of x. So you could kind of just like change the values for x and y. Like you could, since you can plug in any value, you just need to get x is let's say x is equal to 0, then it's 1. Then y you just need to make it 3. So that's just 1 times 4 is 4. So if you think about it, x you want this x plus 1 is equal to 1. It's just 0. So x is equal to 0. Or if you want x to equal to 4, that's just 3. Or when you want x equal to 2, it's just 1. This is 2 again, so you can't repeat it again. You want x to be equal to -1, it's just -2. X to be equal to -4, you just make -5. And x to be equal to -2, you just make -3. So determine the sum of all possible values of x. Let's just cancel out some of these numbers out. So -3 and 3. You don't have to do 0 is nothing, so we don't have to do anything about that. So -5 plus -2 is -7, plus 1 is -6. So the answer for number 19 is -6. Number 20. One digit goes into each box. For example, 1 across is find the product of 5 and 7. For example, if the 1 across is find the product of 5 and 7, the first box should be 35. Also, there are no leading zeros in any of the entries. For example, 40 is okay, but 04 is not. Right answer as the order pair A, B, C, D. Okay? So using this chart, 1 is a prime number. We can't do anything with that across, so A and B, basically, we don't know because there's a lot of prime numbers that are 2 digits. 2 is a multiple of 14. Maybe we could work with this, but let's not for now. There's only a set amount, but there is still like multiples of them. 1 down, a number that has the same units digit when expressed in base 8. So, that is something we could do too. 2, same concept, multiplies at 13. So it has the same units digit when expressed in base 8. So 8, 2 is a multiple of 14, and multiples of 14. We have 14, 28, 42. So let's kind of use your calculator for 14 plus another 14 is 28 plus 14 is 42 plus 14 is 56 plus another 14 is 70 plus another 14 is 84. Just to make sure we're right. And plus another 14 is 98. So these are the only 2, 4, 6, 7. 6 possible answers for 1 and 2. Or AB. And then 1 down, which is BD, it has to be multiples of 13. So we have 13, 26, 39, 42, 52, 65, 78, and 91. So 2, 4, 6, 7. This also is 7. So since it says expressed in base 8, that means there is no possible number that's 8 or above. Because like if you're writing in bases, what it does is that it kind of like you can't write like 79 base 8 because 8 is greater than 9. Because if you're using base 8, you're using like a number system where that's what when we're using base 10, we're basically counting from 0 to 9. So that's 10 numbers, and that's why it's base 10. So if you're using base 8, it's just 0 to like 7, and you can't use 8 because 8 doesn't exist. So number 1, which is A and C. So 14, when we have 14, you can't have anything higher than 8. So this thing is canceled out. So we only have possibilities 1, 2, 4, 5, and 8. So when you're writing in base 8, you multiply the tens digit by 8, and then you add the units digit to get like the base 10 version. So a number that has the same units digit when expressed in base 8. So 1, using if we have 1 here and we have 1 here, because it could be 1 1 wait, sorry. 2 power of sorry, CD has to be base 8. So yeah, these cannot work. And AB has to be prime number, which is 1 across. And we have a single number that's expressed in digit in base 8, so which is 1 down. And this is 13. So this has to be a multiple of CD has to be a multiple of 14, and BD has to be a multiple of 13. So we need to see if that's possible. So 1 and 4 means that the D has to be 4, so one of them has to have a 4. Since it doesn't have a 4, that means actually 2 down, sorry. A 13. Does one of these have a 3 in the end? None of them work, so this cannot be possible. We have 26. There's a 6 here, so it's possible for that to work. 39. There's no 9 here, so that doesn't work. 52. There's a 2 that works. 65. There's no 5 here, so it doesn't work. 78. There's an 8 here, so that works. 91. There's no 1 here, so it doesn't work. So we only have a 6, 2, and 8. So 6, 2, and 8. So you can't get the 14 and get the here because it doesn't have anything with theirs. So those are the only numbers that we could use. We could use a 28, 42, and 56. And corresponding with those is the 26, a 52, and a 78. So let's move this up. So the first thing is you kind of just write all the possibilities and you kind of just like cancel all the ones that don't make sense. So these are what we have left over. So 28, 42, and 56 is the base 14. So let's just kind of, since there's 3 possible cases, which is just basically those, so we just like write 3 boxes. That's basically how I do it. So 14, base 14 across is let's say it's 28, 42, right, and 56. And then multiple of 13 down. So this is 78, 52, and 26. So based on that, I could immediately say that the second case doesn't work because they say across a prime number. So AB has to be a prime number. But since this is base 5, it's going to be divisible by 5 already. And since I could also cross this one out because it's base 2, I mean, its answer is 2. So it has to be an even number. So it's divisible by an even number. So by 2. So these 2 cases don't work. So the only case that works is the 28 and the 78 right here. So let's move that up. Actually, we're not going to use this anymore. So we have the 28 and the 78. Oops, sorry, a little too big. Okay. So you have the 28 and the 78. So this is the only combination. So A has to be a prime number. So A could be 1, that makes 17. 2 is 27, which is divisible by 3. Doesn't work. 3 is 37. That works. 47, also prime. 57 is divisible by 3. And 67, that works. 87, that is also divisible by 3. And 97. And you can have 07, so that doesn't work. So we have all these possibilities. So now we just have to do 1 down, which is AC, a number that has the same units digit when expressed in base 8. So when it's 1, 3, 4, 6, 12, you have to put 1 here. So 1 down is 12, or this is 32. That's 42, or that's 6 and 2. That's 62, and then that's 92. So as I said before, it cannot be 9 because it's going to be in base 8 because you can't count higher than 7. So technically, we just need to look at all these numbers. So base 8, if this is base 8, this you just subtract 8 from here, so that's a 4. Subtract 8. You can only subtract 8 one time, so you put 1. So the units digit is 4. So base 8, usually how this works is just 8 times a 1 is 8. And then plus the unit digit, which is plus 4. So that makes 12. And that's how it's, and that's in base 10. Because this is in base 10, so it's 112. So base 8 is 1 and 14. So it's 14, so that doesn't work. So 32. 32 is divisible by 8, which is just 4 0. So base 8. So 8 times 4 is 32, plus 0 is 32. So this doesn't work. And cross these out. Now we have 42. 42 with base 8. 40, that's 16, 32, 40. So it could go up to 5 times. So that's 52 base 8. So 8 times 5 is 40, plus the 2 is 42, so that's 42 base 10. So these are the same thing. So since they both have the same units digit, this and this works. Now let's test the last one, which is basically just 6 and 62, which is just 62. So 62, you put a 7. So 7 times 8 is 14, 28, 56, 56. So this is 6, base 8. So 7 times 8 is 56, plus the 6 is 62. So this is equal to 62 base 10. So I always do this to make sure that it's the right conversion. So basically how I do it is that what's the highest number that I can multiply to 8 that's lower than 62, which is 7. And then whatever I subtracted from, so that's 7 times 8 is 56. 62 minus 58 is 56 is 6. So that's the units digit. So 6 would be the units digit. So based on this, that means this also doesn't work. So the only possible value is when a is equal to 4. So the answer for number 20 for A, B, C, D is 4, 7, 2, and 8. So that's the answer, 4, 7, 2, 8 for A, B, C, D. That basically covers everything for the CCML Algebra 1 Contest 5 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.